Algebra 2, 7-6, common logs. So a common log is a log that has a base of 10. So base 10 logs. And they are commonly written, they look like commonly written, where if I have log base 10 of x, we just write it as log of x, where x is greater than 0. Remember, x can't be 0 or a negative number in a log. On a calculator, if you end up with log base 10, so remember, if there is no base written here, then you know it's a common log, and the base is 10. On a calculator, you can use the log key on the calculator. So you can just take your calculator, and we can do an example here. Let's do an example. Log base 10 of 5, right? So common log of 5. So all I do on my calculator, clear everything out, and I just press the log button, is right here. Log of 5 equals, and I've got point is approximately 0.6990. So on the calculator it's 69897. So the 7 gets rounded up to that 9, which anyway, blah blah blah. This is how it properly rounds. Let's try another one. Log 0.3 is approximately, so go ahead and plug that into your calculator, or if you have a phone, I believe you can do the log when you turn your phone sideways. You get a lot more buttons on the calculator. Let's go ahead and try that. So if I turn my sideways, so I've got log. Now notice on my, this is an iPhone, and on my iPhone I've got log base 10 here. So it even tells you the common log here is base 10. So let's see, I'm assuming that for this one, let's see how it works. I'm assuming you go 0.3 and then push the log button. Let's see if that's what it does. Yep, there it is. So on this kind of a calculator, you push log, and then you put in what you want to find the log of. 0.3 equals negative 0.5229 when I round it. Same thing with this one. But on my phone, I push the numbers first, and then I push the log. Notice here there's this ln key. That's natural log. We're going to look at that coming up, but not today, but very soon, probably on the next lesson. So on the calculator we have negative 0.5229 is what that would round to. Right. Now let's look at some. We're going to go like this, and we're going to draw a little kind of diagram chart here for the way we can look at these logs. So if I have the natural log, common log of x equals y. If I were to take that y and jam it up in here, that's going to give me 10 to the y equals x. If I have log of 1, common log of 1 equals 0, that's because if I take that 0, jam it up in there, 10 to the 0 equals 1. Any number raised to the power of 0 equals 1. Okay, let's keep going. If I have log base 10, right, common log of 10, that equals 1. And so the way we can look at that is jam that 1 up in there and you end up with 10 to the power of 1 equals 10. We're going to look at one more. Log base 10 of 10 to the m power equals m. Why is that? Because if I were to jam this 10 up in here, or this m, then I would get 10 to the m power equals 10 to the m power. Notice both bases are the same, m equals m. So whatever m is going to be my answer here for this. Log base 10 to the 10 of 10 to the m power equals m. Okay, let's see if we can use any of this information here. Solve exponential equations. Exponential, that's what I was thinking of the last lesson. Solve exponential equations using logs. Okay, so here's an example. I've got 4 to the x power equals 19. Okay, 4 does not, there's nothing I can put here like cleanly that's gonna 4 to the something gets 19, right? I can do 4 squared, 4 to the second power, that gives me 16. 4 to the third power gets me 64. So that's not gonna work. So what I can do here is I can take the log of both sides. Log, I'm going to take the common log, log base 10, of 4 to the x power equals log base 10 of 19. And I'm going to use my power property to take this x and put it over here. And so now I have x times log of 4 equals common log of 19. Now all I need to do is divide both sides by log of 4. And so I have x equals the log of 19 over the log of 4. So remember, we're talking about common log here. So log base 10. So now I can take this and plug this into my calculator. So I have my common log of 19, close parentheses, divided by common log of 4, close parentheses, equals 2.123, I'm going to have to round that, okay, to x is approximately 2.1240. Now, let's try another couple. I've got 3 to the x power equals 15. And what I'm going to do here, so I can't, 3 to the third is 9, 3 to the fourth is 27. No, 3 squared is 9, 3 cubed is 27. Whew. Okay. So let's go ahead and take the log of both sides. Log of 3 to the x power equals log of 15. So I'm taking the common log again, base 10. You can take this x, put it over there. X times the log of 3 equals common log 15. Divide both sides by the common log of 3. And so x equals common log of 15 over common log of 3. I'm going to plug this into my calculator. I'm just going to say log of 15 divided by log of 3 equals, and I'm doing approximate here because I have to round, 2.46, again with the rounding, 50. All right, one more. Let's have you guys do this one on your own. 6 to the x power equals 42. All right, go ahead and take the common log of both sides, get through here, put this into your calculator, and see what you get. Go. Okay, let's see how you did. I'm going to take the log of both sides. 6 to the x power equals common log of 42. X goes over here. And since you're in Algebra 2, I'm going to kind of do 2 steps at once. I'm going to divide natural log of 6 as well, and I end up with x equals log of 42 over the log of 6. Plug that into my calculator, and I should get 2.0860. Now, if you can't get your calculator to do what I'm doing here, you can take the log of 42 and say, what does that equal? 4 decimals. You can take the log of 6, 4 decimals, and then divide those two. That's another way to do it. That might not give you this exact answer, but it's going to get pretty close. So you might be off right around here, and that's okay. I mean, we want it to be as close, as accurate as we can, but sometimes calculators are a little bit funky and can't totally do this computation the way that this calculator does. So let's go ahead and do a few more examples here. Let's solve some inequalities this time. So here's an example. 3 to the 5y power is less than 7 to the y minus 2 power. So I don't know what I'm doing here. I can't get this 3 or this 7. I can't get these bases to be the same. And so what I'm going to do instead is take the common log of both sides. So I'm going to take the common log of 3 to the power of 5y is less than the common log of 7 to the power of y minus 2. Now I'm going to take this y minus 2, plop it down in front, take this 5y, plop it down in front. 5y times log of 3 is less than y minus 2 times log of 7. So remember, if you don't see what this base is, you know it's 10. Now I'm going to divide both sides by log of 3, and then I'm going to solve for y here. So these problems are kind of a little bit of a pain in the butt, but it's just the way it is, and you just have to kind of hope we don't have too many of them on the homework. So at this point, what we could do, instead of dividing stuff, we could just find the log of 3 and multiply it by 5, and the log of 7 and multiply it by negative 2 and by y. Let's just do that. That might be easier. 5y times log of 3. So I'm going to take the log of 3, and I get 0.4771 is less than, what's log of 7? Log of 7 is 0.8451 approximately. So I'm going to say, I'm going to distribute this here. Y times 0.8451 minus 2 times 0.8451. Kind of gross, but it's all right. So now I need to multiply these things. So I'm going to say 5 times 0.4771. I've got 2.3855y is less than 0.8451y minus 2 times 0.8451, which is 1.6902. Subtract from both sides this 0.8451y, because I want y by itself. So I got 2.3855 0.855 minus 0.8451, and I end up with 1.5404. Y is less than negative 1.69. Was it 02? Yes, 02. Divide both sides by 1.5404. And so now I have 1.6902 divided by 1.5404. Y is less than negative 1.0972. Whew. There it is. Kind of gross, but it's okay. So instead of giving you another example here for us to work out together, am I going to give you one? I would like to move on here before we get too long in this video to show this last little bit. Change of base formula. And here it is. I've got the log base A of n. Here's what this equals. It equals log base B of n over log base B of A. A cannot be 1, B cannot be 1. Now, let me explain this. So see this n here goes in the numerator, A goes in the denominator, and you can put whatever base you want here for this B. So I recommend here that you use 10 because that's how you can use the calculator. So let's do an example, see if we can figure out how this works. Log base 3 of 11, I want you to evaluate this. So I can't say this equals x and go 3 to the x equals 11. That's not going to work. I'm not going to be able to find x. So what I have to do is use the change of base formula. So I've got log base 10 of 11 over log base 10, or the common log of 3. So that this one goes in the numerator, this one goes in the denominator. So now I can plug this into my calculator and get an answer. Let's just have you try changing the base. So you have log base 3 of 20. Change the base here. So let's see how you do. Make it look like this. Okay, go. All right, let's see how you did. So what I'm going to do here is I'm going to say common log, or log base 10 of 20 over the common log of 3. So that's how you change the base. You take this one, put it on top, this one, put it on the bottom. Make sure you have a base that is going to work for what you want, and you're done. So let's do one more, and this time we'll plug it into the calculator. Log base 5 of 140. So I'm going to change my base, and I've got a common log of 140 over common log of 5. So now I can plug this into my calculator. I can't plug this into my calculator. Some fancy calculators you can do this, but most calculators you can't. So you've got to change the base, and then you can plug it into your calculator. So I have log of 140 divided by log of 5, and I end up with approximately 3.0704. And that's how you do the change of base formula. And that is the end of 7-6. Good luck on the homework.